So for the second part of these notes, we're going to look at the ones that contain polyatomic ions. Now remember what I told you about these polyatomic ions. You can tell something has polyatomic ions if the ending part of the name ends in ate or ite. So one of the things I suggest that you do at the very beginning is to make sure and write in or underline any eights or ites that you see. The other thing that you want to notice is our three, you know, outside of the mold polyatomic ions that we have to recognize: cyanide, ammonium, and hydroxide. Those are three that do not end in ate or ite, but they are polyatomic ions and we have to recognize them as such. So cyanide is our Cn minus, remember, ammonium is our NH4 plus, and hydroxide is our OH minus. So watch for those. So for lithium sulfate, we're going to do the same thing that we did on the previous set of notes. We're going to write our ions. Lithium is Li. It's in group 1A on your periodic chart if you look at your charges. So it's going to have a positive 1 charge. Sulfate, we know it's a polyatomic ion, so we look on our polyatomic ion list, and we see that sulfate is SO4 with a 2 minus charge. Same situation as before. We have 1 positive but 2 negatives, so it looks like we need another positive ion to get this to balance. Once we have that, we have our 2 positives and our 2 negatives. We know this compound has lithium and sulfate in it, and since there are 2 lithiums, we know we need 2 Li's here. If we don't need to multiply that polyatomic ion by anything, just leave it alone. We'll see a different situation come up next. Look at chromium 3 nitrate. We don't even need to look up chromium. It very nicely with that Roman numeral told us that its charge is 3 plus. Since nitrate ends in 8, we know that nitrate is a polyatomic ion. I get lots of just N's here, but an N is nitride. Nitrate is a polyatomic ion. We look it up and we see that nitrate is NO3 with a negative 1 charge. So it looks like here, in order to get our charges to balance, that we need 2 more nitrates. We need another nitrate and yet another nitrate here in order to get those charges to balance out, because now we have 3 positives over here with our chromium and 3 negatives with our nitrate. Now look at what happens in this situation. We have chromium, and it says we just have 1 of them. We have 3 nitrates, but look at what would happen if we just put the 3 after that. It makes it look like we have 1 nitrogen and 33 oxygens. So anytime and only if you need to multiply something by the polyatomic ion, you're going to put it in parentheses. And that's going to indicate to us that we have 3 polyatomic ions here, 3 nitrates to go with that chromium. Go back and look back at lithium sulfate. Notice that we did not put any parentheses around lithium sulfate, around the sulfate, because we didn't need to multiply it by anything. And if you do put extra parentheses around something that does not need them, I will take points off for that. So our next one, copper 2, we don't have to look that up. It's automatic 2 plus. Cyanide, on the other hand, we might miss that one and start trying to look up cyanium or something like that on the periodic table. But we have to remember that that's one of our polyatomic ions that kind of breaks outside of the mold. And it doesn't end in ate or ite, but it's a polyatomic ion, Cn minus. So if you notice, we've got 2 positives, but only 1 negative here for cyanide. So it looks like we're going to need another cyanide to get us our 2 negatives and 2 positives. So we know it has Cu and Cn in it. And we know we need 2 cyanides. Now this is where people mess up time and time again. They'll just put a 2 out here after cyanide. But think about it. If you do that, that's telling you that you have 1 carbon and 2 nitrogens. We don't want 1 carbon and 2 nitrogens. We want 2 cyanides. So once again, no matter what, if you have to multiply those polyatomic ions by something, they must be in parentheses. Our last one over here is zinc phosphate. I'm going to erase off the chromium data real quick just so that we can not be so congested up here. We've got zinc. Zinc isn't always true, so zinc is going to be a 2 plus. It is a transition element, but it's one of our always true transition elements. It's always going to be a 2 plus. Phosphate ends in that ATE again, so we look it up and find out that phosphate is a PO4 with a 3 minus charge. I'm going to teach you a little trick. It's called crossing charges. And the beauty part of this trick, yes, we can write up 2 more zincs to get our 6 positives and 1 more phosphate to get our 6 negatives. But if we've got a 2, this always works for a 2-3 or a 3-4 combination, we can do something called crossing charges. And I'm going to do this in green so you'll realize you don't have to have it on your paper. But what that means is when everything is all said and done, again, it's just a shortcut, that when I write zinc and phosphate, that the charges will cross. This 2 becomes the subscript for phosphate, and this 3 for the 3 negative for phosphate becomes the subscript for zinc. It's just a bit of a shortcut. And so you can do that crossing charges on a 2-3 combination. It can be 2-3 or 3-2, and a 3-4 as well. Those 2 always work. The other ones don't, so don't try to use it. It'll work sometimes, but not always. Or we can go back and do our old tried and true writing out our polyatomic ions to make sure we've got all of our charges balancing. Just a shortcut to use if you wish.